Okay, good evening, good afternoon, depending on where you're dialing in from. And again, I'm Dr. Reggie Taylor. I'm from the Office of Research and Doctoral Services. And this evening, I will be introducing you to the one sample t-test. Now, we know that these are most of the time aligned with the research courses and the one sample t-test, and really the family of t-tests will be coming up here. So we tried to align these with those. It provides you with the anxiety reduced state that you need to get through those application assignments. But as I also mentioned, that regardless of if you do quantitative or qualitative research, a well-constructed literature review will encompass a exhaustive review of the literature, meaning, that you will include quantitative and qualitative literature regardless of what methodology you are employing. So, it behooves you to become very comfortable with understanding the quantitative research, regardless if you're going to do that or not. So I think that everyone should get some benefit from what we're going to do here this evening, okay? So what we'll do here is I'll go through a few housekeeping notes. And then as normal, we always talk about our main objective is to ease anxiety. You're not going to leave here a statistics expert. You're not going to leave here a one sample t-test expert, but you're pretty much hopefully going to get an overview and a good understanding of the test, what it is. When you understand it, when you see it, you understand what you're looking at, you're able to even conduct one of these tests. But anyway, as I always start out and have showed the importance of, as anyone that have attended any of these previous sessions, again, is the scales of measurement. By typing or saying yes, does everyone see that the scales of measurement thus far has been very, very, the need to understand that has been very, very important to everything that you've done up to this point, if you're actually taking the research course, because everything we do in SPSS is based on that scale of measurement of that data that we're going to do something with. So we won't spend a lot of time on that, but we'll just revisit that real quickly because we know that we have some resources for that. And then we'll jump right into the one sample t-test. What is this t-test? Of course, we'll talk about some data assumptions associated with the test and the application scenario. And again, this is for those who are enrolled in one of the research courses that align with this, and you have an application for that week that the t-test is going to be discussed. So we'll take a look at that application and hopefully help prepare you from understanding that application when you get to that point. And in doing so, we'll be looking at SPSS version 29. You may see some slight differences in some of the versions. You may have 28, you may have even 27, even earlier. It's just some minor differences. You just have to click maybe one or two more buttons to find where something is, and then everything else pretty much falls into place. But of importance is that once we run this one sample t-test, what's important is that we want to understand and be able to interpret that output. And what does it mean? What does all this, as we call it, gobbledygook in the very beginning, and it turns out to be something that we're able to understand and write about and not just click buttons. And, that's very important to what we do here. But then we have to take it a step further and learn and identify how to write a correct APA compliant results section when we run a t-test. Then how do we present those results? And in doing so, for those that have attended previous sessions, I always leave you with an exemplar, an example that you can use or take advantage of if you feel the need to do so. Now, what I've added in this session is that the link, and we'll get to a slide where we'll look at some upcoming seminars, which in essence will be the seminar tomorrow night for the paired samples t-test or the repeated measures t-test, and then Wednesday night for the independent samples t-test. So if you haven't received that invitation from other sources, you'll have the links here to be able to register for those sessions. Okay. And of course, there's always a survey that I encourage you to complete, because that's what drives the needs for these seminars and drives me continuing to do these and align them with your quantitative needs. And the recording for this will be the first place that you'll be able to find it will be out here on the YouTube channel, and you'll be able to use the presentation to click on that link to get to the recording, which should be out there hopefully sometime by midday tomorrow. Okay. So in housekeeping, again, this session is being recorded, okay, and it should be available within 24 hours. And these are the URLs that you can go to. The one on YouTube will definitely be up there first. If you don't see the one at this link or it's definitely the one at YouTube will be there first. Again, we're using version 29 of SPSS. If you're using earlier versions, you may see some differences in what we're doing, okay? As always, let's please mute our lines and be courteous to others. It's my responsibility for you to have a safe, friendly, and non-intimidating learning experience. And also, very important is that this is not a general statistics seminar or a complaint seminar. And what we have to focus on is the abstract. Individuals' time is very precious, and we've taken an hour out of our time, and we all are expecting to get a lesson on the one sample t-test and anything associated with that, okay? So remember, the first thing that we want to do is to get us from the state on the left here to the state on the right, where we have eased anxiety. And that is the overall goal. You will always have the recording to go back to, you'll have the presentation to go back to, but hopefully after this, within the next 45 minutes or so, you'll be able to sit down, take a deep breath and say, okay, I understand, where it is that I have to go and how I need to get there, okay? And that's what we want to accomplish here. Now, again, the scales of measurement, which we're not going to spend a lot of time on because you have a link at the bottom there for the scales of measurement in-depth video tutorial. But we know everything that we do in SPSS now, and when we look in an SPSS data file, that each data or each variable has a measure in that measure column, and it's going to either be nominal, ordinal, interval, or ratio. And what we're going to be looking at when we talk about the one sample t-test is that we're going to need to use a ratio scale of measurement is what we would need to use. And we'll take a look at that. We wouldn't want to select a nominal or an ordinal or an interval category. We want to make sure it's a ratio variable. Now, when we look in SPSS, we'll note that we said we have 4 types: nominal, ordinal, interval, and ratio. But we'll note that in SPSS, we only see 3 types. We see the nominal and we see the ordinal. But what we don't see is the interval and ratio. Well, the scale will substitute and takes place for the interval and ratio. So again, that's very important to understand that when a data measure calls for an interval or ratio, that you won't see that in SPSS, but what you will see is scale. And you will want to select the scale, okay? So that's what we would be looking for when we run the one sample t-test. We'll be looking for that scale measured variable, okay, for sure, to make sure we're on the right track. Now, let's talk about this one sample t-test. Now, many of you, I see the names and I know that we've been doing this for a few weeks. And what we've done in the first few weeks is that we have kind of described data. Remember, we ran descriptive statistics and we looked at ways of reporting descriptive statistics. How many males, how many females, or what percentage of this or what percentage of that. We did that with tables. We even did it with graphs. Remember that we did the graphical displays of data. We were doing pie charts and box plots and things of that nature. And that's called descriptive statistics. But now what you're moving into is that in research, after you describe this sample, this data that you have collected, and you kind of describe the sample to get an idea of how many of this and how many of that, then you have to actually run what we call inferential statistics. Okay, so the two terms are descriptive statistics, and now we're going into and entering the phase of inferential statistics. And just as the word says, infer, we're now going to go from a sample and we're going to be able to infer to a larger population. And that's what we mean by inferential statistics. We know it's very expensive. It takes time. If we try to conduct research on some entire population, we just can't do that. It's not feasible. So we have to select the sample. And from that sample, if we do things correctly, we should have confidence in inferring and saying these findings also, are evident in the broader population. And the one sample t-test is the first test that we're going to discuss. Now, what is it? It's a parametric inferential test. And I just mentioned inferential. We're going to infer to a broader population. But what do I mean by parametric? You probably have come across the terms thus far, parametric or non-parametric, where a parametric test is a test that has data assumptions, and we have to test those assumptions. You've probably heard of the terms normality and things of that, no outliers in the data. And we've looked at that again. Recall when we did descriptive statistics, we ran things to let us know, are there outliers, et cetera. So when we do an inferential test where we have to look at these types of data assumptions, we call it a parametric test. And of course, you're becoming familiar with hypotheses. But what does this one sample t-test do that other tests are not appropriate for? Well, what it's going to do is compare mean scores. And we know from descriptive statistics that our mean score is the average now. We know, so we're going to compare an average scores against a predetermined is the important word, predetermined value. Now, where does this predetermined value come from? Well, in research, it comes determined by the researcher, or the literature may lead you to understanding what test value you should be comparing an average against. Well, let's look at this research question, which should really help us understand this. So what we're asking here, is there a statistically significant average GPA difference, GPA scores, between a sample of Walden students? So what we have to do is, with 30,000 plus Walden students, what we have to do is go in and get a sample of those students, and we collect and get their average GPA. But we know that the national online GPA average is 3.0. So remember when we said a predetermined test value, that is the predetermined test value here, 3.0. And we want to know, on average, do our Walden students have an overall higher GPA than this national online average of all the students taking online courses? How well do we line up against other universities around the nation in terms of our GPAs? That's what we use the one sample t-test for. And notice it says one sample, meaning the only sample and the only data that we're going to have is that one sample from Walden. We're not going to have two samples where we're comparing the samples. We're comparing one sample against a predetermined value. Okay, is everybody okay with that? And again, with the research question, we're just going to have, the corresponding null hypotheses that there is not a difference and that there is a difference. And you'll see that when we get into SPSS to run the test, it's going to ask us for a test value. And what we simply going to do is enter that value of 3.0. Is everybody okay up to this point understanding the concept of the one sample t-test? Okay, fantastic. Now, let's take a look. We know that we're saying that of all the online institutions in the US, that the average GPA, the Department of Education has that data, and they know the average GPA score is 3.0. Now, but we want to know, how does Walden line up against this 3.0 national average? Now, this is Walden. But we're not going to use all of Walden students. We're going to get a sample, okay, from Walden. And if we do our sampling right, random sampling, etc., all of the greens, which are samples, will let us know that we can infer whatever we find back to the total Walden population. So again, our one sample will be what we select from the total Walden population. And remember, we are comparing against a value that's already been given to us. And you'll see how this aligns with the upcoming application that you'll be faced with, okay? Now, here's the scenario that you'll be faced with if you're taking the research course. And they're saying something about an international researcher wants to know something about perceptions about current levels of democracy, as you can see, which I have underlined in red. Now, again, so there's some hypotheses that due to reforms in Africa, that the views of democracy have changed. So they're kind of giving you a scenario. But basically what they want to know is compare attitudes before and after the reforms, but they would want to see a value of 6 on the scale. Now 6, and they would like to compare it to a value of 6. So 6 would be what we would call that predetermined value. Does everybody see that? And so from a sample, we're going to see if the responses, on levels of democracy are significantly higher or lower than 6. Okay? And this is exactly what you'll have to do, provide a 1 to 2 paragraph response to that provides this information, and that's the exemplar that you'll be provided. But we're going to actually take a look at that. So does everybody understand what this assignment is asking as it pertains to the one sample t-test?
Yes, I do have a question, if you don't mind.
Sure.
So what does when it says on the scale of 1 to 10, should we be, so that right there would throw me off. Does that mean?
Okay, they're just telling you that that's how they measured the data. But you'll see once we get into SPSS, that'll make sense to you. Okay, so keep that in mind, the scale of 1 to 10. Okay. So now, but we know now that this is what we call a parametric test. And we have to test these assumptions. And each test that you're going to be working on, starting this or whatever week you're starting with the t-test and on to the other tests you're going to be running, ANOVAs, regressions, etc. Each of those tests are parametric tests, and they're going to come with data assumptions. And they will differ based on the test. So we are talking about the one sample t-test tonight. But what are these assumptions? And they are merely those characteristics about the data and the distribution of the data, basically. Remember when we looked at other graphs and things and see how the data was skewed and all those? So if the data violates that normal distribution type shape and other type things that we're going to talk about, it changes your conclusions. You're not quite sure of the results. And so the results are kind of shaky. And we need to let the researcher know that. So you don't go back and recollect data because you have what you have. And in real life, as you can see in the second bullet here, real life data violate these assumptions. What you are charged with as the researcher is understanding, what do I do with these assumptions? What are they and what do I do with them? You don't have to go back and collect data. When you collect data and you run descriptive statistics, oh, my data is not normal. Don't panic. Now we move to the next step of research and say, okay, now I know that I have to assess these assumptions, identify them, assess them, and then take some actions if they're violated. So we're going through the temporal order of answering a research question and using, statistical analysis to answer those research questions. Okay? Now, so basically in the research process, you always, when you open up that data set, you're going to assess those assumptions, and we're going to talk about that before you run the one sample t-test. You're going to identify the results. Did the data meet those assumptions, or did the data violate those assumptions? If the data violated those assumptions, we don't just press on. We identify that they were violated, and you tell us what actions you took. After you take those actions, you simply then run the regression, and you'll get the results of your one sample t-test. Okay? Now, let's take a look at these assumptions for the one sample t-test. And the two that you're worried about in SPSS will be down here in red. The first two are what we really call design assumptions. You really know that you have to have that scale data. Okay, so when you go into a data set, you're just not going to select data that's not scale. Okay, so that's what we mean by that. You don't have to test that or do anything. You just need to make sure you select that scale variable. Okay. And then data are independent, meaning that the data are not related to each other. You don't have to worry about that. But what you're really concerned with is normality. Someone was detected at your front door. Outliers. Remember when we did the descriptive statistics, we looked at normality and to see if the data was skewed left or skewed right, whatever the case may be. And we knew how to test that. We're going to do the same thing again. The same procedures we did to assess SPSS, normality, and the same procedures that we did for outliers. So as you can see, it's the building block. But you have already done this if you've attended one of these previous sessions, or if you have taken the research course this term. You've already assessed and understood normality and outliers. Okay? So now let's pretend that we're in SPSS. And let's take a look at what we would do. From the main screen, you would hit the analyze. And these are the exact same steps we did when we were looking for normality and outliers in our descriptive statistics. Remember, we select descriptive statistics. We select explore. We come up here to bullet number 4, normality plots with tests. Okay? And that's going to let us know if the data was normal or not, the normality test. Okay? We hit continue. And when you hit continue, you guys remember when we looked at the box plot before? And remember the assumption of normality? Here's the test of normality here. So what would we say here? Was the assumption of normality violated here? What would your take be here? Yes, because it's less than 0.05. So we would say that the data that we have collected didn't meet the assumption of a normal distribution. Does everybody see that? Okay. So you'll be looking for the test of normality when you get the SPSS output. And you're simply, again, are going to assess the SIG column against this always standard 0.05. Does everybody see that? We good to go? Okay. Now, the other thing that we get, because we asked for the graphs, we get the box plot. And remember, we've produced box plots before. Now, if anyone that attended the sessions before, would you say that, okay, let's just take a look at this first to make sure we understand it. We're looking at GPA scores. Remember, we want to know how Walden compares to the national GPA average. Here, the GPA scores here, 4.0 being the max, down here to 2.8, okay? Would we have any outliers in this data set from what you recall when we looked at box plots before? Looking at this box plot, would you say that we have violated the assumption of outliers? Yes or no? 2 responses only. No, and why would you say that? Looking at this box plot, why do you see that there is no outliers? What would let you know that there's no outliers there? Remember, when we look at the box plot that has outliers, it will have there'll be, let me actually just make them the color here. They'll actually be the little dots that would be outside of exactly no cases beyond the inner quartile whiskers exactly within there. Yeah, excuse me, you're right, within the whiskers. I'm sorry, down there like that. And so we don't see anything here. So remember now, just from our visual inspection, we don't see anything out of the ordinary with our outliers. So we would say that that assumption has been met. So then we simply now can move on and let's run the one sample t-test. So remember, again, you just follow the arrows. It will be analyzed. You're comparing means. Remember, you're comparing the national mean of 3.0 to this unknown Walden mean of the sample that we have selected, and it will simply tell us one sample t-test. You know now all your variables will show up here, and you're going to select that scale variable. And remember, from the tips and tricks, we knew that the variable that has the little ruler is a scale variable. But we're going to also look in the data set and make sure we know what a scale variable is. Remember, that's a scale variable, ruler. This would be that nominal or categorical variable, etc. Okay? Then, once we get the output, this is the results. And you see, this is a very simple test. So as you can see, we know now that it was a sample of 80. The average Walden score was 3.66 with a standard deviation. And we remember we talked about that in previous sessions. But now, remember the test value is 3.0. So what we're comparing is these two numbers now. 3.0 against 3.66. We know they're different, but we want to know, are they statistically significantly different? And we always look in the significance table, and we look at two-sided. Was there a statistical difference between Walden and the national average? Anyone want to take a stab at that? Is there any statistical difference significant difference between the Walden sample? Yes, it is. Yes, it is. And because this mean difference here is positive, that means that we are a little bit higher, significantly higher than the mean of 3.0. And that is the answer to the research question. Now, the next thing that you'll have to do is then simply put the APA right up together. Okay? Excuse me. And as you can see, we're just simply going to state what we did in one sample t-test. And again, we just almost restated the question. You know, we're looking for that difference, that GPA mean difference between Walden and the national GPA of 3.0, which is the test value. Again, we'll see the test value will show up here. the preliminary analysis, these were the assumptions. Remember, normality and outliers. And we say here in this example, just looking at the chart here, okay, GPA scores were not normally distributed. And the reason why, and in this particular run here, the Shapiro-Wilks test, as you can see, is less than 0.05, okay, over here, the test of normality, remember? So just get your eyes comfortable with knowing where to look. So when I talk about normality, I'm comparing that to 0.05, and it's less than that. Then what we would have here, let me see. And I said there were no outliers in the data. So then we would have looked at, remember, the box plot, and we would not have seen any of those little dots beyond the whiskers. And, we'll say it's assessed by the box plot, okay? Now, this is the piece here. Now, the analysis, the results of the one sample t-test were significant. And this is the statistical notation that you will be presenting. You will start out with the T, letting us know that this was a t-test. Remember now, you're going to start reading journal articles, quantitative articles, and you're going to see T's, and you're going to see F's, and you're going to see X's. That's going to give you an indication as to the type of test that was conducted, okay? Now, you know that there was a t-test conducted. The 79, right here, in parentheses. You see right here, the GPA degrees of freedom, 79, right here. That's what you put in here. But remember, we're going to go more than just putting numbers in here. We want to know what these numbers were. This number, 79, notice the sample is 80. That is the sample minus 1. So n minus 1. So you can see now already, just by looking at this, there was a t-test with a sample of 80 people. Do you see that? Already, it was a t-test with a sample of 80 people, just by looking at that information there. Just by looking at that information. Now, it says equal. So what we're reporting here was what was the t-statistic that was calculated by SPSS. And you'll see here the 18.52 is the t-value that was calculated, okay? And then, of course, the significance, the p was less than 0.001. That comes right here from the two-sided p. Does everybody see that? So we know that a one sample t-test was done. It was 80 people in there. And we know it's compared to a GPA of 3. And we know that it was a significant difference. Right there. That tells us more than any words can tell us. Very efficiently and effectively. This is what you want to get comfortable to seeing and understanding as we work through the various tests, okay? So far, so good. Yes.
Yeah. So on this slide, you note that, quote, the reader should judge these results with caution because the GPA scores are not normally distributed. So my question is there a point at which when you're looking at the data and its distribution, if you do not have a normally distributed data set for that particular variable, when does one not proceed to do a one sample or other parametric test because it's not normally distributed? I thought that was one of your going in assumptions.
Yeah. What it is, this is just for training purposes. A lot of times you'll see that, and especially in doctoral research, a lot of times the student will just say, I know there's some abnormalities in the data, so, judge these with caution. But beyond the scope of this session here, there are other things that you would do. For example, if you had outliers, you would remove the outliers. But if you had normality, also too, depending on the statistical test, once you really get into the purity of statistics, a test such as the one sample t-test is very robust against the assumption of normality. So it's really not a concern, but again, that's a little bit more in depth. But that's a good question there that that really gets into a little bit more in-depth discussion, but good question there. Yeah. So then what you always must do also is provide the effect size, okay? The effect size, and again, the t-test is going to give you what's called the Cohen's d report. And as you can see, it's right here, the Cohen's d value, and it's the point estimate was 2.02. And that's a very large effect size. In your literature and what you're reading, I think you should see that Cohen says, well, an effect size of 1 is 1, obviously, but 0.0 to 0.3, I believe, is small, 0.3 to 0.6 or something is medium, and 0.6 to 1 is large. This is extremely large because it's higher than 1. So really, what it means when they're asking you, and let me jump back to this this exemplar, not the exemplar, but the application. Comment on the meaningfulness here. Okay, everybody see that. Comment on the meaningfulness. In inferential statistics, this p-value, believe it or not, means absolutely nothing. What it means, and I'm sure you guys are going through that this week, but what it truly means is that the mathematicians have said that based on your research with the degrees of freedom of 79, and you're looking for significance at 0.05, that the computer, listen to me now, the computer calculates a value of 18.5. The computer. Now, when your value is calculated based on your numbers, those two numbers are compared. So basically, this was your calculated t-value, but behind the scenes, there's another t-value where these two numbers, so this 18 is being compared to something behind the scenes. So that's a mathematical probability that you would get, a p-value of this size. But that means absolutely nothing in research, really, because what is the magnitude of that difference? That effect is what they're talking about in your application when you're talking about meaningfulness, okay? So make sure you discuss the effect size when you talk about the meaningfulness. Now, because this is an example and it's just hypothetical, in real research, you would really be able to talk a lot about that because an effect size in one situation may be very meaningful. In another situation, it might not be meaningful because it's case specific. But the point I'm trying to make to you is that when you're talking about the meaningfulness of it, you're talking about the effect size, okay? And this is a very large effect size here, okay? Now, what does that mean? I mean, it could mean a lot of things. We're doing things right here at Walden, or we have exceptionally, it could mean a lot of things. It's not cause and effect. Now, remember, this is not an experimental design. But again, in real research, there's a whole theory put behind what you're doing to ask this one research question. So please keep that in mind there, that this is all very hypothetical. But the meaningfulness piece, what I want to get over to you is that you're going to talk about the effect size, and that's Cohen's d. And you should be reading up on the effect size, I believe, in this week here. Okay, does everybody understand that? And then yes, the confidence intervals should always be included too. But again, you'll see here that you're going to report the confidence intervals down here for the mean difference. So you see the mean difference is a very important number, that mean difference was 0.66 points of a GPA. Okay, but the confidence interval would be as low as 0.5, okay, and as high as 0.7. So you report the confidence interval, but for this test, you report the confidence intervals for the mean difference, okay? So you should and must put that in there, yes. Confidence intervals are very important too, because now that's meaning. That's meaning that, remember the week that we talked about confidence intervals and we explained what they were. And that meant if we replicated this study 100 times, then 95 out of 100 times, remember that we know that the true mean would be as low the mean difference would be as low as this 0.59, but as high as this. So you see, other than this p-value here, we're starting to give a lot more information. The effect size, the mean difference, but how low that mean difference could have been and how high that mean difference could have been. Does everybody see that? These are the important pieces of information that really start explaining data more so than the p-value. Does everybody understand that? From a very conceptual basis there. Okay, and that's what you want to talk about when you talk about the meaningfulness of that. Now, let's do something here right quick. Give me a second. Now let's take a look now at the exemplar that I'm going to give you. Okay, now you should see a one sample t-test exemplar. Remember, I've been giving you something like this in the previous weeks. Does everybody see that on the screen? Okay, fantastic. So again, remember, I always usually put an abstract together, but then again, you know, in the forward information, I'm telling you where you can find additional resources here. And this is the YouTube page over here where the recordings will be. But let's look at this. Now we're looking to see here if there's a statistically significant mean, remember the average difference in perceived stress. Perceived stress is what we're measuring how between Walden University's unknown population mean. Remember, we didn't know what the GPA was. We knew what the national average was, but we know that the perceived stress score is national 25.0. So what would we call the 25.0 in this research question? What would we call this in the research question or in SPSS? So what is this? What is this value here?
Is that the test value?
The
Or
predetermined value, yes, the test value, the predetermined value, exactly. Exactly. Now, and then remember, not conceptually, we would be getting a population of Walden students and see, you know, how much stress we perceive we have, you know, against the national, you know, online average. So I want you to understand conceptually what your one sample t-test is doing, okay? And so again, we just have the null and the alternative hypothesis does not exist and it does exist. But look at here, you'll have this example and you'll see that the one sample t-test, and again now, for application purposes, we're showing that we know some knowledge of the test and what it's used for. You know, it's used to determine whether an unknown mean differs from, you know, you provide a citation there. You note down in the bottom, I'll give you some footnotes and things to help, you know, learning resources. And again, I have a second support for what the t-test is appropriate for. But then I go right into what the test was done. It was done to determine, you know, there's a difference between Walden and the 25 average. Remember, we report the results of the assumption test. Remember, we're going to assess as outliers and normality. Now, in this case, good example here, I said 2 outliers were identified and retained in the analysis. I could have removed those from the analysis. Again, it's just going to be different reasons for doing that, and it's nothing that we could really say yes or no, don't do that based on a hypothetical situation. And then we say the normality assumption was violated, okay? And we put the p-value from a Shapiro-Wilk test. So then in this case, again, just for training purposes, I'm saying The reader should judge these results with caution. So perhaps maybe in real life, I would remove those two outliers and rerun the analysis, and it may even fix the assumption of normality issue. But again, just to get the idea, that, that's kind of how it works.
Reggie, again, I have a question for you.
Yes.
Yeah, so if you were looking at the alternative hypothesis on the slide, or the null, if the wording were different in that the alternative hypothesis was that the Walden University sample, you would expect a higher stress compared to the national average. Not a difference, but a higher. Would you then use the one-sided
Yes, that would be a one-sided test. Yeah, but it's a whole lot of, issues with one side. But yes, this would be from the two-sided test. Yeah,
right?
That would be a directional hypothesis. You're correct.
Right, exactly. Just wanted to confirm that.
Yeah, this is a sample of and even you can even put in there, sometimes with one sample t-test, comma, two tails, comma, so it just depends. Yeah, but yes. So now the next thing we're going to do is then just report the results. And as you can see, we simply state the results of the one sample t-test were significant. Remember, we're going to get the t, and in parentheses, again, what is the 433? That will give us some indication of the sample size. Remember, n-1, that would be that degrees of freedom. So we now know this is a pretty large sample here, 434 cases. Remember, that's that calculated t statistic, and it came out to be significant. Remember, the effect size, Cohen's d, 0.295. That's somewhat of a small effect. But again, the mean difference, remember, this is important for the one sample t-test. The difference, the mean difference, was the 1.727. And here I just put the confidence intervals for that here. As low as 1.118 and as high as 2.228. You see the upper limit and the lower limits, than the national, higher than the national average, which is, again, is the predetermined or the test value. And just a statement, the null is rejected and the alternative is accepted. And again, on average, but notice in this example, I have a figure here. Okay, figure 1, which shows the two outliers. And this is the example of the box plot that would show you that there are outliers, and it would tell you exactly which cases in the data set were outliers. So that would be case number 10 and case number 19. Now, as the researcher, you determine what you're going to do with that, okay? But this is just a very brief example to kind of show you, how to basically report the results, and basically address the basic application. Now, you'll have to put output to support your results. And again, notice here that, again, here's the box plot. This is the test of normality. Remember the Shapiro-Wilk test. Here is the one sample statistics up here to the right, which again shows the mean score. Remember the n, the sample size, the degrees of freedom, the significance. And all you're doing is transferring this into that narrative write-up that we just saw. But you understand now what a lot of this stuff means. Again, remember the mean difference, okay? And then down here, you're going to have your Cohen's d point estimate effect size. And again, the 95% confidence interval for that point estimate. So it could be as low as 0.199 to the left, or as high as 0.391 out of 100 random samples. 95% of the time it's going to fall within that range. Now, the other thing that you have to do is provide syntax. And you'll recall that from previous sessions that we looked at how to do syntax. And now we're going to get into SPSS and show you how to do this syntax piece, okay? So what I'm going to do now is, give me just a second. And SPSS. Okay. And let's actually just open up that Afrobarometer data set that you folks will be working on, okay? And so when you open that data file up, Remember in SPSS, you have data view, you have variable views, and I'm just expanding the columns here. And right now, I'm in the variable view, okay? And basically, this is letting us know what variables, and you have to do something on some variables with the perceptions of democracy. See that? Democracy today. So you would be selecting one of the variables in this range. You see, level of democracy, level of democracy. Remember, that's what the application or the scenario is asking you for. Now, there was a question earlier about 1 to 6, so the numbers. Well, it's a scale variable, and in the assignment, it tells you that it goes from 1 to 10, from 0 to 10. So you can see it's from 0 to 10 are the responses that should be in the data view. And we're going to take a look at the data view. But remember now, it's a scale variable. Scale, these are scale variables. Okay, and these are the democracy variables that you are going to be selecting one of these. Now let's take a look at the data view, okay? So this was the first one, because it goes right to the level of democracy today. And you can see these are the different responses in numbers here. And again, we can look and see, they have the numerical score. This person scored it as a 1, a 4, a 5, this person a 4, etc. And you're trying to see, on average, are the scores in here significantly different than that 6.0, okay? So let's do that. So we were going to get into analyze, okay? And again, remember, you're going to compare means. And in comparing means, you have the one sample t-test is what this scenario is for. And we know that's the test to compare a sample to a test value. Now, exactly as you will see when you look at your presentation, you'll see that you have the test variable and you have the test value. So remember, you're going to take one of those. Let's just look at level of democracy today right here. And I'm going to put that in here. Remember, it's a scale variable, and I want to compare it against 6. That's what the assignment is telling me to do. That's what you'll be doing. You got some options in here. Let me see what these are. Remember the confidence interval, keep always at 95%. Hit continue, and you hit OK. And you'll be presented with output that then you can make the write-up from. So taking a look at this, I know this looks pretty small, but if you can see that, can you tell me if there's a significant difference between the levels of democracy today and the mean score or the predetermined value of 6? Anyone want to take a stab at that? Anybody? Yes, P less than 0.001. Exactly. You understand that now. You know exactly what you're looking at. The mean difference was negative this time, remember? So it was lower. So the overall level of democracy was lower now. Remember, you see the negative was lower by 0.555. So that perception of democracy, whatever it is, from high to low, it's it's less now, significantly less. Again, with the 95% confidence intervals here. The effect size, now don't worry about the negative in the effect size, just look at the absolute value. But the effect size of 0.15, 0.15 of one standard deviation. Does everybody see that? The sample was 11,614. And the average score was 5.54. Okay? Does everybody see that? Does it make sense now? Have we lowered anxiety just a little bit? And we kind of understand now what we're trying to do. So remember, you've already been told what your predetermined value is. It's 6. Let's go back and make sure that we're on the same page here. If we go back to the, give me a second. We've been told what our pre-value is. If anybody puts in anything other than 6, then shame on you, okay? 6. And remember, levels of democracy, and it was just on a scale of 1 to 10, and that's just telling us, what the rating scale was when they collected the data, okay? Now,
So
and we want
I'm
to know,
sorry, can I ask a quick question?
yes,
So, okay, so you're saying that the scale for 1 to 10, 6 is falling in between the 1 to 10. So anything that would be over 10 would not even, I guess, register?
no,
Is-
it's like, have you ever been asked on a Likert scale, how satisfied are you with something on a scale of 1 to 5?
Uh-huh.
All they're saying is that when they collected this data, they asked them a question and it went on a scale of 1 to 10. All they're doing is telling you how the data was set up.
Oh, okay. Okay.
Okay, yeah. And
Thank you.
now, because it was set up from 1 to 10, they arbitrarily say, let's see if we're significantly lower than, or higher than 6. Okay?
Okay, thank you.
Now, you're going to select everybody. So when you come back in here again, everyone, remember, let's look at one more example. Analyze. Remember, compare means. Remember the one sample t-test. Okay. Now, I'm going to take this one out, which is the current level, and let me just take a look at level of democracy 10 years ago is what that one is. Okay, I'll put that one in. And what the perception, again, the test value is 6. It doesn't change. We hit OK. Let's look at the bottom one. Was it significant? Anyone care to take a stab at it? Bingo, you're experts.
Yes.
You are experts. You know that there was a significant difference. You know that that mean difference was lower because it's negative. It was lower than 1.077. You know the effect size, 0.356 here. And you know the upper and lower limits of the effect size. And then that, my friends, would turn into the APA results that we just looked at. Does everybody understand, excuse me, conceptually now what we just did? And really understand now, and have we kind of lowered the anxiety about the one sample t-test? Can we say that we have done that?
I don't know if I would say my anxiety is lowered, but I
Okay.
kind of understand it. Kind of.
Okay. Well, if you kind of understand that, that falls under the realm of anxiety being lowered. So we'll
Okay.
say we're moving in the right direction. Okay. But you'll have this to go over and over and over again. It will be there for you to look at the recording, and you have course readings also. So collectively, you'll understand, kind of what you're doing here. But I'm sure
Reggie?
you have a little bit more of understanding than just opening up that data file without having attended this session and saying, where do I go? What do I do? So again, that's the purpose of this, to give you some kind of a preview, a precursor of what's going on, and more so even understanding what the test is doing and why you would even do it. Because in a lot of cases, you would never even perform this test, but you would be reading studies where these tests were conducted. That's the important piece, really. Do you really understand? Do you really understand what you were reading there? Okay.
Hey, Reggie,
Yes.
can you do me a favor and go back to the summation slide on the stress between Walden sample and there's the one sample t-test, so you had a summation slide. No, where you actually state the summary of it. Okay. Let me just take a look at this a second. Is this the stress one? No, it must have been another slide. Yeah, it's sort of you summarized the differences in stress between Walden students, and it's not this one. It's the sort of conclusion slide on how you would summarize the findings.
Well, that was an exemplar. That was an exemplar.
Yeah.
Yes.
Yeah.
This is the exemplar that you're going to get. Mhm.
Um,
Doing the same thing that we're doing here, just use another example. Mhm.
no, it was a different slide. No, maybe.
Okay, I'm not quite sure, but I'm going to move on because we're going past an hour here now. But
Yeah,
the
that's
other
okay.
thing that I
You might
want
want to just quickly. You might want to check your slide on that.
okay, I
Summation.
will, but we can discuss that after I finish the session here. You can
Okay,
stay
sounds
for a
good. Sounds
second
good.
if you want to.
Sorry to interrupt. Yep.
No problem. Okay. So what we're going to do here now is give me a second here. The next thing, remember on the one of the overview slides, we mentioned that we would talk about the upcoming session. So tomorrow night, if you haven't got the introduction or the invitation to that, you can use the PowerPoint to just go to this link and register for the dependent samples t-test, which will be the second scenario in your t-test week. And then Wednesday night, we'll do the independent samples t-test, okay? So again, it'll be the same format, but it's where you register for those sessions, okay? And make sure we get through all these slides. Remember, as always, we want you to go out here for all of the recorded resources that we have out there. Please go out to the slide to the link here for the survey to let us know, if this is helping you. Should we provide you with more? And again, this is what we've ran through here. Again, remember, the survey can be achieved from right here. The recording link, hopefully by sometime tomorrow, you should have that there. So now the next thing that I'm going to do is now we're going to take all of the documents that you need and put into the chat. Okay, so you should be seeing these documents show up. So give me, just a second, and okay, there should be a PDF of the presentation that you should see in there now. Okay, so go to the very bottom, and the next thing that I'm going to put in there is going to be the exemplar. Okay. And there you have it, okay? So please double check and make sure that you have everything down at the bottom there and you're able to retrieve that. If not, you know how to reach me via email to get anything that you may not have gotten and retrieved during the session. And again, please be sure to register for the sessions the rest of this week to help you as you go through the 3 applications for the one sample t-test. Okay, so is everybody feeling a lot better now? We think we have what we need to get through the one sample t-test? All righty. That's what we like to hear. Okay, and so I'll see hopefully many of you tomorrow night. But remember, if you're not able to attend, you can always go out to the recording that should be out there for the paired sample t-test and the independent sample t-test. Again, if you're not able to attend. Okay. So thank you for your attendance. I'll leave the class open for just a second and make sure that you get the documents out. Okay.